Hello everyone, MKS here. This session will revise indefinite integration before your board examination, and I'll be discussing all important concepts, the formula required, and a few very important sums which you need to revise before your board examination. The topic I have selected today, indefinite integration. You know, indefinite integration is considered as the reverse process of differentiation. So if there is a function fx, its derivative d dx of fx is equal to f dash x, then you know integration of fx dx is equal to fx plus c. This c is called integration constant. In indefinite integration, this is compulsory to write the value of c over there. If c is there, the value you get here, it is general solution, and the geometrical significance is that if you consider this one as another function gx, then gx will represent a family of curves. This you need to remember. Geometrical interpretation of the indefinite integration, it represents a family of curves. But if you know the value of c, then you get the particular answer over there, then you get a particular curve. Otherwise, if plus c is there, it will represent a family of curves. And here this function fx will be referred as primitive, and we say that fx is the integrand because you are integrating this. This is called integrand. The basic formula of integration, it is x to the power n dx, x to the power n plus 1 by n plus 1. Dx integration is x only, dx by x log x. If there is a to the power x, it will be a to the power x by log a, plus c must be there. E to the power x integration is e to the power x. Let us revise a few sums based on the concept, based on the formula you have just seen that here. If you want to integrate this, you need to make cubing of this thing. X cube, 3x square, root x means x to the power half, 3x into root x square is another x, minus x to the power root x is x to the power half, its cube will give you x to the power 3 by 2. Each time when you integrate, you get an integration constant, but we will write only one integration constant over there. This will give you x4 by 4 minus 3. This is 2 plus half will give you x to the power 5 by 2 dx plus 3x squared dx minus x to the power 3 by 2 dx. On integrating the second term, it will give you 5 by 2 plus 1 by 5 by 2. This one is 3 into x cube by 3 minus x to the power 5 by 2 by 5 by 2 plus c. Simplify it to get the final answer. There will be x4 by 4 minus 6 by 7 x to the power 7 by 2 x cube 2 by 5 x to the power 5 by 2 plus c. Only one integration constant will be written. Don't write integration constant for every part of the sum given. For the second problem, a to the power x plus b to the power x whole square, if you want to evaluate this, you have to expand this one also. A to the power 2x, 2 a to the power x, b to the power x, b to the power 2x, that divided by a to the power x, b to the power x. If you start separating a to the power 2x by a to the power x, only a to the power x will be remaining. So a to the power x by b to the power x dx plus, here also on b to the power x get cancelled, b to the power x by a to the power x dx. So it is a by b to the power x dx plus 2x integration of b by a to the power x dx. So this sum is based on the basic formula of integration. This a by b will be treated as a only. So if you write the answer for this part, it is a by b to the power x by log a by b plus 2x log b by a, only one integration constant. For the next one, if you want to integrate this you need to factorize x square x minus 1 2x minus 1 by x minus 1 dx. So it will be x square plus 2 into this by this to get cancelled, x square dx 2 dx. X square integration is x cube by 3 2x plus c. And for the fourth one, if you want to integrate, here it is f dash x given and f1 equal to 0 given. Whenever this kind of condition given, it is going to be a particular solution. Only one curve you will get after integration. So you just write this one as d dx of fx equal to 3x cube 5x to the power minus 2. 1 by x square is x to the power minus 2. Now this fx, if you write, then you are integrating both sides. It will be 3x cube dx minus 5 x to the power minus 2 dx. This is x4 by 4 minus 2 plus 1 by minus 2 plus 1 plus c. So it is 3 by 4 x4 plus 5 x to the power minus 1 by x plus c. This is fx. One initial condition is given over there. I told you, if initial condition like this thing is given, f1 may be 0 to whatever one condition is given, then you will get the value of c from this calculation. So put x equal to 1 on two sides. For x equal to 1, f1 will be 3 by 4 plus 5 plus c. But f1 is given to be 0. So c is going to be minus 3 by 4 minus 5 minus 23 by 4. So the curve you get this manner, fx equal to 3 by 4 x to the power 4 5 by x minus 23 by 4. It will represent one curve only, not many. Plus c will give you many by changing the value of c by depending on different values of initial condition. You can get different value of c, but if only one condition is given, you will get one value of c. This is the answer finally. Now integration of this form you may get, then you will divide the answer by a. Okay, in derivative you multiply, in integration you will divide. So when you are integrating this kind of thing, when it is function of ax plus b, it is normal integration of that thing divided by coefficient of a. That's why we need to remember a few formula based on it, like when you are writing say e to the power ax plus b dx. What is the formula for it? It is e to the power x only, so it will remain e to the power ax plus b, divide the result by a plus c. What about ax plus b to the power n? This concept you need to keep in your mind. Ordinary integration like ax plus b to the power n plus 1 divided by n plus 1 into a will be there. Okay. So if the integrand given f of ax plus b form, you integrate and divide the result by a. Another one, if fx to the power n f dash x dx is there, then you can write the result fx to the power n plus 1 by n plus 1 directly without any substitution. Just I give you one example from here. Say we have a problem like this, x squared to the power 30 dx, and before that 2x dx is there. Okay, so derivative of x square is given over there. This answer you can write x squared to the power 30 plus 1 by 30 plus 1 plus c. So there will be x to the power 62 by 31 plus c. This is the concept. Now if the function given this form f dash x by fx, answer will be log of fx. Like suppose a problem given this manner, e to the power x into x plus 1 dx, that divided by x e to the power x whole square. Okay, no, just x e to the power x whole square means then it will bring a complication here. The question given this manner. So you need to check whether the numerator is derivative of denominator or not. d dx of x e to the power x 1 into e to the power x, and this plus x e to the power x. Numerator is that only. So the answer you can write directly log of mod of x e to the power x plus c. Hope you all have understood this one also. Now let us apply these three concepts you have got here. Like on integration you will divide, and if fx to the power n f dash x is there, you will use the formula fx to the power n plus 1 by n plus 1. F dash x by fx is there, you will put log of fx. I have selected some problems to explain, to practice more on it, because if you remember all those forms, then answer you can write in one step only. Whether it is MCQ or descriptive, it doesn't matter. You can write the answer. See, ax plus b to the power n form. So here it will be 3x plus 10 to the power 5 by 2 plus 1 by 3 into 5 by 2 plus 1. n will come there, n plus 1, and coefficient of x will come down. This I told you earlier also. So it is 3x plus 10 to the power 7 by 2, and this is 3 into 7 by 2 plus c. So this is going to be 2 by 21, 3x plus 10 to the power 7 by 2 plus c. Alright. So the direct application of formula is possible here. How to proceed with this sum? This one we need to rationalize. You multiply numerator and denominator by 2x plus 3 minus 2x minus 1, and here it will be 2x plus 3. This rationalization you are habituated. I just remind you few sums of this kind. This is 2x plus 3 to the power half, 2x minus 1 to the power half, denominator contain 2x getting cancelled, 3 plus 1, 4 dx. Alright. So 1 by 4 will be there outside, and here it will be 2x plus 3 to the power 3 by 2, half plus 1 3 by 2, minus 2x minus 1 to the power 3 by 2 by 3 by 2. This you can easily simplify. After that you will get the answer. How to proceed next one? This is also direct form. Dx by ax plus b. It will be log ax plus b or minus b by 8 plus c. So remember all these. Your MCQ on indefinite integration will not be a problem at all. Now for this one, it is of the form a to the power mx plus b. Formula you can modify, or that ax plus b form you just remember. Here m is the coefficient, so its integration will be a to the power mx plus b by m log a base e plus c. Base e you need not repeat. So for this one, the answer going to be a to the power 5x plus 9 by coefficient of x is 5 here, 5 log 4 base c plus c. Next one is a very good problem, very important also. Why? Because this is based on one important manipulation here, that which you have done in class 11 already, like e to the power log x. If nothing is stated, base is exponential, value is x. Okay. So here in your problem, there is e to the power 2a log x. E to the power 2a log x. This is e to the power log of x to the power 2a, the value is x to the power 2a. E to the power x log a, e to the power log of a to the power x, no base means e base is there, it will be a to the power x. So for this particular sum, you just make this conversion before and then you do it. So this is changed to what? This is changed to x to the power 2a plus a to the power x dx. This is nothing but 2a plus 1 by 2a plus 1 a to the power 2x by log a base c plus c. Finished. Okay. Now we are going to remember indefinite integration by substitution and how to substitute. See, when you are going to substitute, a suitable part of the integrand should be replaced by another variable. Then suppose the variable is z, then the whole integrand will be changed in terms of z and then integrate. Like for this one, this you do not direct formula how to manipulate this. But once you make a substitution here, then the problem can be, whole integral can be changed in terms of the variable you are assuming for it. Like if you are taking let 2x minus 1 equal to z or z square, then it will be easier. So 2 dx will be equal to dz. So dx going to be dz by 2. So I will be what? Integration of get x from here. X is z plus 1 by 2. 3x will be this plus 2 multiplied by root z into dz divided by 2. Okay. The x is changed in terms of z. Now we can integrate easily. You just take the LCM. 2 is the LCM here. 3z plus 3 plus 4 z to the power half dz by 2. So there it will be 1 by 4 3z plus 7 z to the power half dz. Alright. So this is changed to 3 by 4 z into z to the power half, 3 by 2, 7 by 4, alright. Now this you write 3 by 4, z to the power 3 by 2 is what? 3 by 2 plus 1, 5 by 2 by 5 by 2, 7 by 4, z to the power 3 by 2 by 3 by 2 plus c. Now what you have to do, you never forget to do it, that z should be replaced. Most of the students do mistake here, they don't replace z by 2x minus 1. You need to replace z by 2x minus 1. So this is 3 by 10, 2x minus 1 to the power 5 by 2, 7 by 6, 2x minus 1 to the power 3 by 2 plus c. Alright. So this is a substitution based problem. You cannot do it without substitution. Now how to do this problem number 2. This is 2x minus 1 by x plus 2 dx. Make a substitution. X plus 2 equal to z. So the I changed to what? Only it can be changed in terms of z. X is z minus 2. So 2 into z minus 2 minus 1 by z dz. Alright. So this is changed to 2 into dz minus 4 minus 1 minus 5 dz by z. So 2 dz means z. dz integration is z. z is x plus 2 minus 5 log another x plus 2. This plus c will be there. How do you solve this one? X plus 1 whole square there in the denominator. How to solve it? You put x plus 1 equal to z. So dx will be dz. I is equal to x, again will be replaced, z minus 1 whole square plus 1 by z square dz, z square minus 2z plus 2 by z square dz. Alright. Now separate, integrate and replace z by x plus 1. So this will be dz. If you separate 2 dz by z plus 2 z to the power minus 2 dz. You understand? It will be z 2 log of mod z 2 minus 2 plus 1 by this plus c. So here it will be z minus 2 log mod z. Finally z you have to replace by x plus 1. 2 log x plus 1 minus 2 by x plus 1 plus c is the answer. Next one, whenever you are going to substitute, you have to see which part is derivative of the other part of the integrand. Here, if you just have a closed loop on this sum, you can see that x when divided it will give you by x minus log x. Do we need to solve it? No, because it is of the form f dashed x by fx. Derivative of x minus 1 by log x is 1 minus 1 by x. So you put log of mod of x minus log x plus c. Okay, you can, for a descriptive question even, you can write this form directly. Only thing you can show that what is d dx. In exam when you are going 1 minus 1 by x, that will show and write the answer directly. It is of the form f dash x by fx. or if you like to make substitution, you do it. Next one is a brilliant sum, because e to the power 4x given over there, it will not make you to get the sum easily. It is not log form. I need it to the derivative of this thing in the numerator. I will never get it. So what I am going to do there, I am multiplying inner and dr, I mean numerator and denominator, by e to the power minus 4x. So it will be 3 e to the power minus 4x plus 2 into e to the power 0. Okay. So there it will be e to the power minus 4x dx divided by plus 2. Now make a substitution. Without substitution you can, but its derivative is what? Minus 12 e to the power minus 4x. It is not there. So you multiply and divide it. Get that form. Then write the answer. What is its derivative? You have to do mentally. What is the derivative of denominator? It is minus 12 e to the power minus 4x. So one step you write minus 1 by 12 minus 12 e to the power minus 4x dx by, what is this? Derivative of this thing is numerator. So you write the answer minus 1 by 12 log of mod of plus c. Okay. Sums of this form are there in your textbooks, M.L. Agarwal, R.D. Sharma, NCERT study material. You practice from there. Now we are going for revision of sums from standard integrals. Dx by x square minus a squared c, x minus a will be there in numerator, x plus a in denominator. If dx by a square minus x square, log of a plus x by a minus x, and this one log x plus root over x square plus a square. For this one, just a square will be replaced by minus a square. Only these 4 standard integral formula there in your syllabus. Let us work on it. You see, in all these formula, x square has coefficient 1. So if we can make coefficient of x square 1, then our calculation will be easier. We can write the answer directly. Just for example, if we do this number 1 I have taken here, that dx by 1 minus 9x square dx, there is a problem. Coefficient of x square is not 1, but we can make it 1. How to? You just write this as 1 by 9 outside, dx by 9 you are taking common. There will be 1 by 9 minus x square. So 1 by 9 dx by, alright, what's the answer? Dx by x square minus a square minus x square, 1 by 2a log of mod of a plus x by a minus x plus c. You can simplify it. You can simplify it. It is 1 by 6 log of mod of (1 plus 3x by 1 minus 3x plus c). Okay. Now let us go for the second example. In this second example, x square plus 2 is there. So what we need to do there? We need to write the numerator in the form of denominator. You write x square minus 9 plus 11, that divided by x square minus 9 dx. Now separate 11 dx by coefficient of x square is 1, so we can go for formula writing directly. That's why getting coefficient of this x square 1 is very important. X plus 1 by 2a log of mod of x minus a by x plus a plus c. This is the answer. And for next one also similar problem, but here x is there. So on separating this, you understand how to solve the first part and second part separately. For this part, make a substitution. Put x square plus a square equal to z square or z, whatever. Now if you differentiate this, it will be 2x dx equal to 2z dz. So x dx will be z dz. Z dz divided by z. This plus b standard integral. It is log of x plus root over, isn't it? This plus c. Now here z getting cancelled. It is root z. Root z means root x square plus a square. B log of mod of this plus c. It's alright. Next problem, before you start the next problem, I would like to remind you one form. All the formula will remain unchanged if instead of x you are getting x plus k. Suppose the integrand is of this form, x plus k whole square, this is k, plus a square or minus a square under root. What to write? As coefficient of x is 1, so you write this one directly, log of x plus k plus root over x plus k whole square plus a square. Okay? If you are comfortable with this, do it directly, otherwise make a substitution x plus k equal to z. But it is better for a faster method, it is better you express the whole of integrand by method of completing square in this form. For example, when you are going to write this one, the denominator inside root, what is there? You have to make it a perfect square. You write 2 into x into half, 1 by 4. So x minus half whole square minus 25 by 4. 5 by 2 whole square. So this integrand is changed to dx by under root x minus 1 by 2 whole square minus 5 by 2 square. I told you x minus half can be treated as x only. So this is going to be log of x. X means x minus half plus under root x minus half whole square minus 5 by 2 whole square. Okay, little bit simplification will help you to score full mark, otherwise there is a chance of deducting mark. Why? Because on simplification this will give you 2x minus 1 by 2, and this thing only written this form, we got the same form here, under root this plus c. Now this on simplification will give you log of mod of plus 2 into under root this divided by 2 plus c. Now when you write log a by b form, it is going to be log a minus log 2 plus c. Minus log 2 plus c is a constant, another constant, so you can write the answer in this manner, log of 2x minus 1 2 root plus k. C minus log 2 is taken as another integration constant k. Book answer may be given this form, book answer or whatever, board marking scheme may be of this form. This k you need not explain, you can write if you like k equal to c minus log 2. Okay. Next one is another very interesting, very important sum. How to solve it? There is no fx by f dash x by fx form, isn't it? So Is there any chance of getting those standard integral? What you have just seen once before today? Let's see. If we divide, if we can take x square inside, then it is x square plus 1 by x square. This is 3. This is going to be free. We make this observation and then proceed. Okay? You write this as x square minus 1 by x square, and this is x root over x4 okay. So this one is what? You separate 1 minus 1 by x square, 1x getting cancelled, 1x you take inside root. Okay. Now this you write as it is x square plus 1 by x square plus 3. X square plus 1 by x square plus 3. Have I got the desired form? No. This is derivative of something. This part. I want to get f dash x by fx plus something form. So I have to express the denominator inside root whatever there, whose derivative will give you the numerator. Okay. 1 minus 1 by x square you can get if you write x plus 1 by x whole square plus 1. Now make a substitution. Put this dx equal to dz. So this is dz by root over z square plus 1. This is nothing but log of z plus root over z square plus 1. So this is changed to log of, you replace z. Z is what? X plus 1 by x. It will be log of mod of alright. So sum is done. It's a big one, but then marks also will be given accordingly. Now how to do this one? 3x plus 1 by 2x square plus a. I am discussing types. I told you if you revise these types with me today, then there will not be any problem for there will not be any problem in understanding what is going to be done during exam. You will remember it quickly after this session. So how to do it? I remind you, you must have done all these kind, but just I remind you very fast. You check 2x square plus x plus 1. Its derivative is not 3x plus 1. Mental calculation all of you can do. Derivative of denominator is 4x plus 1, but here it is given 3x plus 1. Then what to do? We will write the numerator in the form of some constant. Some constant is L into derivative of denominator plus m, isn't it? Whenever numerator is less index than that of denominator, you apply this method. Now this is 4lx plus L plus m, you understand? Now compare. So comparing two sides, what do you get? We get 4L3 L plus m is 1. So L 3 by 4, 1 minus 3 by 4 is 1 by 4. Now this integrand is changed to a convenient form, the numerator. Numerator is what? It is L into 3 by 4 into 4x plus 1. You are going to get f dash x by fx. Then what is remaining over there? The value of m is 1 by 4. So you separate and write dx by 2x square plus x plus 1. Since derivative of this is there, we write log of, it is f dash x by fx form, no? So log of 2x square plus x plus 1 plus 1 by 4, this you need to change into standard integral. Make coefficient of x square 1 by normal method. It is dx by half x plus 1. Can we convert this one to standard integral form? Of course we can convert. Let's see how to convert it. So this you write, I am writing the second part only because first part is completed here. Only the second part we are going to practice now. This is dx by, you write 2x into 1 by 4 plus 1 by 4 square. So this is dx by x plus 1 by 4 whole square 1 minus 1 by 16. So there will be 15. Use the standard integral to write the answer. Okay, but you can do it, but they are expected to be minus 1. What you will do there at home, you take this one as minus 1 in place of plus 1, then the sum will be justified for you. With plus 1 you will never be asked, please change it into minus 1. This part is also minus 1. Okay, so then for minus 1 this will be minus 1. So minus 17 by 16. So answer will be minus. Now do it. X square minus a square form we have done before also. Do it now. Clear? Hope all of you have understood up to this substitution and standard integral form. Okay? Integration by partial fraction. Here rational expression will be written in this form: a px plus q by x minus a, x minus b. You write a by x minus a, b by x minus b. If there is a quadratic factor, write this manner. If three factors are there, you write this manner. If there is repetition, write this way. If there is a quadratic factor, then for quadratic factor, numerator you write bx plus c. Only these forms you need to practice before exam. Okay? So let us see quickly how to integrate if sums given this form: x by x square plus 1 into x square plus 2. For this one, we first make this is an integrand, no? So write the integrand fully: x dx, that divide by x square plus 1, x square plus 2. You can write two different manner. Remembering there is a quadratic factor, or make a substitution, quadratic will be changed to linear one, then go by partial fraction. If I do all the sums in details every step, then only solving these four sums will take long time. So I am just going to give you the hint for these kind of sums, okay, where integration to be done by using partial fraction. So here you make a substitution: let x square equal to z to reduce the integrand. Okay, then differentiating 2x dx will be equal to dz. You write this one as dz by half will go outside, x dx is dz by 2, z plus 1, z plus 2. You can use partial fraction easily, but I'll tell you not to carry the method with the integrand. What I want to say that you must have done before, that 1 by z plus 1, z plus 2, you write as a by z plus 1, b by z plus 2 by putting values or by comparison. By putting values means considering this one as an identity, you multiply both sides by z plus 1, z plus 2, it will be a into z plus 2 plus b into z plus 1. Then get the value of a and b by putting z equal to minus 2, z equal to minus 1, and then do it. Putting z equal to minus 2, here 1 will be equal to b into minus 1, b is minus 1, then put z equal to minus 1, so 1 equal to a equal to 1. So this integrand now changed to 1 by 2 dz by z plus 1, a by z plus 1, 1 by z plus 1 dz minus 1 by z plus 2. So half log of mod of z plus 1 minus half log of mod of z plus 2. Many students don't change this one in terms of the original variable given over there. They keep their answer this one. There is a chance of losing marks here. It will be half log x square plus 1 half log x square plus 2 plus c. Alright. Now how to integrate this one? I tell you the method here. Already explained, but this integrand you will write 3x by 2, 3x minus 2 by x minus 2, 3x minus 2 by x minus 2 whole square plus 1 by x plus 2. Okay? No. Then let me tell you. For this second problem, what you need to do, you write this integrand, say 3x minus 2 you are writing, this you write as a by x minus 2, b by x minus 2 whole square, c by x plus 2. Since quadratic factor is there, you will write it twice, then cross multiply by putting values of x as 2 minus 2 and another one anything, say 0 or 1, you get ABC and integrate term by term. Now, how are you going to integrate this one? Dx by, 1 by x into x power minus 1. It looks very difficult, but not at all. Here what you will do, you write the integrand first. Dx by x into x square minus 1 on factorization, x square plus 1. What you will do here, you make substitution, make this thing simpler and then use by parts. X dx by x square minus 1, x square plus 1. Put x square equal to z. So 2x dx equal to dz. X dx is dz by 2. So now the integrand will be half z minus 1 z plus 1. Now this integrand, separately you write the integrand in the form that a by z, b by z minus 1, c by z plus 1, and then proceed. Okay. Now for this one, number 4, what to do? Is it a partial fraction sum? Yes, it's a partial fraction problem. What you will do here, you multiply by x to the power n minus 1, both inner and rear, and then there it will be x to the power n plus 1, make a substitution. So n x to the power n minus 1 dx. So x to the power n minus 1 is there. If you rewrite it, x to the power n minus 1, this will be changed to dz by n, that you keep outside z into z plus 1. You can use partial fraction. A by z, b by z plus 1, get a and b by the method I told you earlier. For this one, the integrand you write first, then put log x equal to z. So 1 by x dx equal to dz. This whole integrand is changed to this form, dz by, so this thing dz by z minus 2. Use partial fraction for it. Now I am going to discuss integrand of this form e to the power x into fx plus f dash x. Very important for MCQ question, for 2 mark question, even for 3 or 5 mark question also. And here, when you are going to apply in solving sum, you have to find fx, you have to find f dash x. You have to show, if you are using this result, that integration of this thing is e to the power x fx, then one thing you keep in your mind, that which one fx, which one f dash x, you must show and then write the answer. Suppose for this one, number 1 we are going to solve here. For number 1, which one fx, which one f dash x? E to the power x, 1 by x squared, 2 by x cube. I am just showing you method of solving one sum for your board examination. You just take fx equal to 1 by x square or x to the power minus 2. So f dash x is what? Minus 2 by x cube. So derivative, if this one, this part is fx, this part is f dash x. You can integrate easily. You can write the answer. Answer is e to the power x fx. So this will be e to the power x 1 by x square plus c. Problem is with the next problem. There is no e to the power form is given, just 1 by log x minus 1 by log x square. What to do? This is of this form only. First we have to reduce it to that form. You let log x equal to z. So x is e to the power z. So I change to what form? 1 by z, 1 by z square, and dx is what? E to the power z dz. So put it there. This one has derivative minus 1 by z square. So answer is 1 by z plus c. How to do next one? Number 3. Number 3, directly you can express in the form e to the power x fx plus f dash x. You write numerator x plus 1 minus 2 by x plus 1 whole cube dx. So this integrand is e to the power x 1 by x plus 1 whole square 2 by x plus 1 cube. Okay. So the answer going to be equal to This one is fx, this one f dash x, e to the power x by x plus 1 whole square dx. All these sums you can do by similar method. I am not going to do all the sums, but this you need to practice before your exam. I will be sharing the worksheet with you. Practice these few sums, express in this form, and then write the answer directly. But remember, for board exam you need to show which one fx, which one f dash x. Okay, just let me do another one for you. Number 7 looks bit difficult because 2x is there. Don't keep 2x over there. You make a substitution. Let 2x equal to z. So 2 dx equal to dz. So I will be equal to e to the power z, z minus 1 by z square. So simple. Once you get e to the power x form, not e to the power 2x or 3x. Remember, if that arises in a question, you should change it into e to the power x form. This we did here and we are getting the advantage. We can write the answer in one step only. Minus 1 by z square dz. So the answer is, if this is fx, if this is fz, this one f dash z. So answer is e to the power z 1 by z plus c. Z is what? 2x by 2x plus c. Problem is solved. You must try the other sums from the worksheet. Integration by parts. If you take product of two functions, they are of this form. One function is u, the other function is v. Then it is uv minus v du. Is that clear? Maybe it is not very convenient form for you. So let me write, when there is a product of two functions, you write this one as fx integration of gx minus derivative of fx integration of gx dx. This is the thing. Okay. So derivative of first function will be there, integration of second function will be multiplied, then their integration again. You have practiced many sums on it. Just revise it for this one, log x whole square. Log x whole square, why? It is given this form. That log x whole square, you have to understand product of two functions here. Log x into log x you can't write, because one function has to be differentiated, other has to be integrated. Log x integration you don't know. So you take log x whole square as the first function, 1 as the second function. Then you write log x whole square into dx integration is x minus log x whole square derivative 2 log x 1 by x x dx. These two get cancelled. X log x whole square minus 2. So again you need to use by parts, because log x integration we don't know. We have to get the result of log x integration by using integration by parts again. Log x into 1 you write again. So log x first function, 1 second function, log x is 1 by x into x dx. These two are getting cancelled and it is completed in the next step only. It will be x into log x whole square minus plus dx integration is x plus c. Okay. Now for next one, this is given of the form e to the power log e. This one is e. Okay. This one is e given. So that I told you earlier that e to the power log x is x only. if base is E. So for this sum you write E base and E is there also. So you write log of x to the power n base 10. Keep n outside. Log x base 10 dx. You need to change the base and then use by parts. Log. There is a chance of asking this kind of question because you are applied mathematics students. Log always will be under control. So n log e base 10 integration log x base e dx. This one by parts I showed in the previous sum. You need to complete. This one again will be changed to this form, log z dz form, if you make a substitution log x equal to z. And here it is 1 plus x will be outside, log 1 plus x. So if you are following this rule, LAE, LAE, logarithm, algebraic and exponential will be there. So this is logarithm and this is algebraic. Log 1 plus x will be the first function. You write log 1 plus x, integration of this thing is x square by 2, minimum 3 marks should be given for this sum, should be given, minus derivative of this is 1 by 1 plus x, 2x plus x square by 2 dx. Now we have to integrate this. First part is very easy, x square 2x by 2 log 1 plus x minus half outside. This numerator you write x plus 1 whole square minus 1 by x plus 1. Just method of computing square, because x square, if you want to write x square plus 2x in this form, you have to add 1, you have to subtract 1 also. So it is x plus 1 whole square minus 1. Okay. So now integration will be very easy, that x square 2x by 2 minus half, you separate x plus 1 dx plus 1 by 2 dx by x plus 1. This is log x plus 1 and this is x square by 2 plus x. Okay, just one more step. Plus c, don't forget to write. For the next problem, that I have taken a general sum where you factorize. Sum can be given in different manner. On factorization it gives x minus alpha, x minus beta dx. I just discussed the method, the way you have to do it in exam. You write log of x minus alpha plus log of x minus beta and then integrate by splitting, by writing this one as sum of two, this one 1 and this one the other one. By taking log first function, you will continue. It may be of the form x minus 2, x minus 3. Method is the same. How do we integrate this one? X e to the power ax dx. Very easy. That LAE rule I was telling you. Algebraic exponential. Algebraic will be the first function. So x into e to the power ax by a minus 1 e to the power ax by a plus c, you can write here. This by a and e to the power ax dx integration will be e to the power ax by a, already one a is there, plus c. For this sum, e to the power minus x squared dx, no, x cube also there, you need to make a substitution. Substitution will make the sum very easy. You can get it by previous sum method then. Then what substitution? You can see that x cube can be written as x square into x. So this thing, when you make a substitution, like put x square equal to z. So 2x dx equal to dz. You can substitute there. E to the power minus z into z dz by 2. Okay. So e to the power x into fx form already you have done. You can happily complete this sum, isn't it? You have to take this one first function and this one second function. This one is the big one. It will take time to solve. What we will do here, that lie rule, again I remind you, log will be first, then remaining terms. So here, if you write the integrand by taking log of x plus root over x square plus a square first into x, then derivative of this thing is 1 by, and here it will be 1 plus this into 2x into x dx. X log of x plus this minus 2 and 2 getting cancelled, x square plus a square plus x by alright, one more x square plus a square is there. These two get cancelled, and this is a very convenient form which you have done before. This is x dx by, so put x square plus a square equal to z square or z, whatever you like. And for the next one, log x by this, I told you put log x equal to z. So x is e to the power z. This should be z dx is what? And you have done this kind of sum, isn't it? This you can do it yourself. You can't? Yes, you can. You write z plus 1 minus 1 by, see again we are going to get e to the power x fx plus f dash x form. You just write e to the power z 1 by z plus 1, this minus 1 by z plus 1 whole square dz. So this is something like f dash z, answer will be e to the power z by z plus 1 plus c. Alright. Now integration by parts, we need to remember these two standard integral formula also, root over x square plus a square. It is x root over x square plus a square by 2. A square by 2, it is there in your syllabus. You must take care to remember all these formula. These two formula, not many, only two formula. No trigo is there, only log based. So again, to integrate this, we will follow the procedure we have followed previously. Make coefficient of x square 1, isn't it? This 2 you take outside, x square minus 25 by 4 dx to x square minus 5 by 2 whole square dx, and this will be what? Log of x plus, isn't it, this plus c. So we have used the second formula. First formula similar to this, only in place of a square you are putting minus a square. Remembering it will be very easy. This one you make a substitution, put log x z, so 1 by x dx is dz, z square plus 49 by, no, nothing is there in denominator, it is just z square plus 49 dz. So simple. This will be what? Root over x square plus a square. X root over x square plus a square by 2. You write it. Z root over 49 by 2 plus 49 by 2 log of mod of z plus this plus c. And never forget to replace z by log x. Log x whole square plus 49 by 2 plus 49 by 2 log of z. Log x whole square 49 plus c. Okay, understood? This one is a very interesting sum. You write this as x square minus 1 plus 1 by under root x square minus 1 dx. This by this, when you write x square minus 1 by this thing, will give you root x square minus 1 dx and dx by root x square minus 1. It is sum of two standard integral. One standard integral you did before, the other one is in this chapter only. Okay? All the best. Practice sums from only good sums this time, because before your exam, MLA, RDS and NCERT support material. Thank you.